Prajakta, can you hear me?
Ma'am, I am yet to watch the 10th and the 11th lecture.
Okay. So, all right. So, I'm just discussing a sum that we covered in the previous lecture. So, just see if you get around it. Otherwise, no problem. You can ask me anytime, okay? So, what we had a look at in the previous lecture, which was lecture 11, was this particular sum. So, we saw that X follows Pareto with these parameters, and there is a reinsurance excess of loss treaty in place. And such that 50% of the losses result in no claim on the reinsurer. So, we figured out the value that M should have for this to happen. And then the next question asked us to figure out the average claim amount, net of deductible. So let us highlight the important parts of this question first. So what we have to figure out is average claim amount, right? So we have to figure out expectation of some claim amount. We don't know as yet if it is insurers or reinsurers. Okay, so now they're asking us to figure out the average claim amount net of deductible in respect of the losses that result in some amount of claim on reinsurer. So that result in some amount of claim on reinsurance. So in a way, we know that we have to figure out the average of those claims wherein reinsurer is involved, right? And if I'm talking about net of deductible, what does this mean? So my question goes to Mihir and Sabri. How did you guys interpret this question? Any one of you? Yeah.
Ma'am, if they would have asked about the average claim amount of the reinsurer, only then we would have calculated only expected value of Z. But they have asked in respect with the reinsurance. That means we know that X is greater than M. That is why we have to take conditional reinsurance.
That is why we have to take conditional reinsurance, right? And Sabri,
because
do you have
reinsurance is
anything?
involved.
Yeah, so Sabri, do you have anything else to add to this?
No, that's the same reason.
Would you like to explain us again, though?
Yeah.
What do you understand? Yeah.
So they have told us that we have to take it in respect of reinsurers. So we know for reinsurance, X will be greater than M. So we can directly take the conditional distribution where we know that we have to find basically the expected value of X minus M. We have to find the value of X minus M given X is greater than M.
Yeah, so Isha, what you sent me was the normal expectation, right? So if I were to write, so let me just write it on the board because this is how I guess everyone thought during the start. Even Mihir and Savri did this, I guess. So let me start. So what comes to your mind first when you read this question, and if you haven't encountered such a question before, is that you would like to take expectation, something like this. So you have M, which is, so maybe you want to write capital M, and here you will have f of x dx, and your x goes on from capital M till infinity, right? So these are the cases wherein we involve the reinsurance company, and now I have to figure out what is my f of x here. So can anyone tell me what should be my f of x here? If I have this particular information already. Anyone? So except Mihir and Sabri. So I want Isha, Prajakta, if you understand, Vaibhav and Vanshita to answer this. Or at least do let me know what are you thinking, or if you still don't get what the question is asking from you. And yeah.
Ma'am, what I did was I took normal Pareto only for f of x.
Yeah. So the general thing that first comes to mind is that we have x following Pareto 3,500 here, right? So what comes to mind is that my f of x here will be Pareto same. So what was it? It was 3,500. So you will have Pareto 3,500. But this is not the case because why? We have to read the question again. So it says net of deductible in respect to the losses that result in some amount of claim on reinsurance. So we are already conditioning the claim amounts of the reinsurer on the fact that they are higher than the deductible. So deductible is RM here. Deductible is just another name for M. So we don't do this. Instead, we use conditional distribution. So remember we studied the conditional distribution of reinsurance company, wherein I define another random variable W, which is equal to X minus M, such that my X takes a value which is higher than M. Do you guys remember this? Okay, I want you guys to answer at least a yes or a no.
Yes, ma'am.
Okay, Mihir and Sabri, I don't want answers from you. So Isha, Vaibhav and Manshita, this question is for
Yes, ma'am.
these three. Prajakta, I think you have covered this part, right? Wherein I was discussing the conditional distribution of reinsurance company.
Yes, ma'am.
Yeah, so do you have any doubts?
No. Not
Okay.
yeah.
Okay. So now what I want you all to do is figure out the conditional distribution of the reinsurance company, which is W. So maybe you can figure out f of x and then calculate its expectation, or f of x, then figure out what distribution it is and then just put in the formula, or directly employ the formula of expectation of W that we derived earlier. So again, take your time and I want you all to work with this. And okay. So till then,
Ma'am, in that formula, how will we find out expectation of Z?
how have we defined Z?
Z equal to X minus M. Okay,
X
so it will
minus M.
be normal expectation of X minus like closing the bracket
Yeah,
M, right?
yeah, exactly.
And while finding expectation of X, it will be regarding, it will be like with respect to normal, the Pareto distribution, right?
Yeah. X follows Pareto, right? We know the distribution of X.
Ma'am, for a minute, can you go to the previous screen because I was not there last time that we did this sum. Okay, thank you. I've taken the screenshot.
Okay, perfect.
Ma'am, is the answer coming as 500?
500 for the expectation, you mean?
Yeah, expectation of W.
Send me your working. It's not quite there, but yeah, do send me your working.
Okay. Ma'am, I'd forgotten the minus M, so now is it 240?
No,
Sorry?
no, it's no, not 240 either.
Oh, okay. I'll send it to you.
Ma'am, can you please once again explain what is exactly the second part asking us to do?
What exactly is the second part asking us to do? Okay, so what I said was, so how far have you understood the question? Can you explain that to me? Yes.
I didn't really go through the question like
Okay,
much.
so you must go through the question and invest at least 5 minutes, if not 10 minutes, and then ask me to explain it. And I'll explain only if you don't get it, right? Because I think you should understand, you should try to at least read the question and understand it first, and then explain me, and then I'll see where you are getting wrong or where you might be thinking actually correct. Okay? Sounds good?
Okay.
Yeah.
And I just realized that since our M was the median point, so even if I do like 1 minus 1 minus f of x, I
Yeah.
should get the same thing.
It would still be 0.5, right? I mean, you wouldn't even had to figure out all the chances by substituting all the numbers and everything. You could just write 0.5.
Mm.
But again, if in exam you're writing directly 0.5, you shouldn't do that, right? You should at least write a sentence or two about why do you think the probability is 0.5. Okay? So keep that in mind. But yeah, that's true. Doesn't matter.
But then where am I going wrong?
Yeah, I'm just checking your answer. Give me a minute. Okay, so till then, Mihir, the working that you have sent me, so the answer is actually not correct. So try to see if you can think of something else. I haven't looked at your working yet, so I'm looking at Isha's and then I'll come to you.
Okay, ma'am.
So, Isha, are you there?
Yeah, yes, ma'am.
Okay. So what you did was 250 minus 129.96 divided by 0.5. Is this what you did?
Yeah. I didn't
Okay.
write 0.5 directly. I've written the whole
Yeah.
f of x thing.
Yeah. But basically you got the answer for that as 0.5, right?
Yeah.
The denominator was 0.5 for sure. Okay, so again, so the only problem I can see here is in the fact that you wrote expectation of x minus m in the way you have written. Because if you have a look at the way we have defined z, how have we defined z? Can you tell me? How did we define z?
Z, in the original thing that we'd done, we'd taken z as x minus m.
Z is just x minus m, right? So if you were to figure out the expectation of z, how would you do it?
So, like I said, it would be expectation of x minus m, right? Normal, like
Yeah,
expectation of x and minus normal m.
agreed. So, okay, so when you write it as expectation of x minus m, again, what you have to take into consideration is that here you don't have the all of x, right? Here you are only looking at the expectation of claims which have a value greater than 130, right? Because we are looking at the conditional. So whenever I'm writing about expectation of x minus m, what I have to do is indeed take the integral of it. Take the integral of x minus m. Do you get what I'm trying to say?
Yeah, so it's like if the limits with z were 0 to infinity, then in case of x minus m, they will differ. They will become m to
Exactly.
infinity, right?
Exactly right. So we have the limits changing. So I think I should work with that.
Yeah, I'll do it.
Yeah. So I guess that was really a good try, and I think I should actually try to write this on the board as well, because this is another general mistake that you can do. So let's say I have this formula written here. So Vanshita and Vaibhav, how far are you guys?
Yeah, I'm going through the first part.
Okay, yeah, no problem. Vaibhav, what about you?
Ma'am, I'm not sure I still understand the question.
The first question or the second question
So
you
the
mean?
second part, the average claim amount net of deductible.
Okay, the average claim amount net of deductible. Okay,
Can
so
I just
what?
send you what I've done yet, and then you can tell me further?
Yeah, so just send me on the WhatsApp. Yeah, it's good. So Mahira, I'm looking at your answer right now. Give me a second. Yeah. So Vaibhav, actually what you have written is absolutely correct. You should just substitute in. So, okay, so the first integral that you have in your book is integration of x f of x dx, right? And just ruffle some pages of your book of the previous lectures and you will see a way to solve these integrals. I mean, just substitute in the f of x and then try to save whether it looks like some other distribution, or if not, use maybe some substitution method or something else. And for the rest of it, the m part of it is just the capital F of x, right? So that shouldn't be much of a problem. Do you see it now?
Ma'am, I'll try to figure it out, and if I'm stuck, I'll let you know.
Yeah, please let me know, okay? Don't be sitting idle in your rooms. So just keep thinking at least, and if you do get stuck, just call on me. No worries.
Okay, ma'am. So, does the second question mean like in the first question, it is mentioned that
Yeah,
50% of the losses result in no claim? And in the second
yeah.
question, are we supposed to find the expected value of the like the losses that cause the claim to the reinsurance company?
Yeah, absolutely. Yeah, that's correct. And again, you know what they're asking is, yeah, so that is actually the thing, because see, calculate the average claim amount. What is our claim amount? It is X, right? Net of deductible, that means minus M, right? If I'm talking net of something, it means minus M. And then I'm talking in respect of those losses that result in some amount of claim on reinsurer. So which claims will result in any amount paid by the reinsurer? What is the condition?
Will be greater than M.
Exactly. So what you have to figure out is expectation of x minus m, given that x is greater than m, right?
Okay, got it.
That's it. So you just have to break the question and then figure out individual parts and then just club them together. That's all that there is every single time.
Ma'am,
Yes,
can
I
you
actually didn't really go through.
Yeah. Someone else was saying something?
Ma'am, can you explain the third question once, because even I got the answer at 92.5.
Oh, okay. So just wait a minute, guys. Um, Still a second question with this, guys. So just
Okay, ma'am.
give me a second. Yeah. So when I'm talking about average claim amount, I have X. If I'm talking about net deductible minus M, and if I'm talking about this is conditional on X being greater than. So something being conditional. Yeah. Okay. So this is what the blue talks about. This is what the pink talks about. And this is what the yellow talks about.
Ma'am,
Yeah.
so when we are writing expected value of z equal to x minus m into fz of x, right? So, like, why are we writing it as fz of x?
So what exactly is fz of x? I mean, so okay, what you can do is maybe just don't substitute z. Just write expectation of x minus m and put the correct integrals, because the only mistake in your solution was the limits, right? Nothing else. So only if you change the limits, you will get the correct answer. So again, instead of writing f of z, maybe try writing it in terms of x, because we do know all the information about x that there is required of us, right?
I'm in the expected value, how can I change the limits? Like, because earlier I
Oh,
directly substituted it as the mean, right?
yeah. So what I am telling you is, instead of writing it as z times f of z, just substitute in the value of z. So whenever you are writing, even before putting the integral, write e of x minus m, and then try to see how would that integral look like. Instead of trying to figure out expectation of z, which might seem a bit. So does that make some sense? And again, whenever you are writing f of z, what it means is that what is the chance that z will take this particular value, right? And again, m being a constant wouldn't change the chance of a particular value being observed, right? So how do you define your z? Z is just x minus m, right? So whenever your x will take a value of z plus m, that will be, so I mean, whenever I'm saying or whenever I'm talking about f of z, what does it imply? It implies a particular value of x, which when we subtract m from, gets us a particular value of z. So I don't think.
Ma'am, can you just check what I've sent
Yeah,
you? Like,
yeah. So that's absolutely correct. Go forward with this. This is correct. Till then, I'll see what Mihir and Saudi have did. So,
Ma'am, and what I've sent you, how should I solve the first part? That is integral m to infinity x into f of x.
So did you substitute in the f of x function?
No.
Try that.
Ma'am, I'm still stuck there. Can you help me out?
Can you send me your working?
I just wrote x into the f of x thing.
Yeah,
But
so I think,
like, there the
so,
x is with lambda, right, in the bracket below. So how can we do anything about it?
so you can take all the constants outside, right? And then you'll be left with only the terms that contain x within the integral, right? And then try to see what can you do, or at least can you use all the techniques that you know to solve the integral? Because I think we have solved such integrals before. So maybe try to see the previous sums that we have done so far. And if you still
Okay.
don't get it, yeah, do let me know if you still. So Savri, I was looking at your detailed solution and I actually cannot find a flaw in it. So let me just check once again. Oh yeah, and again, I would say, when you're writing f of x within the integral, make sure you write a small f because I really can't differentiate between the small f and capital F of yours. I mean, that's just a little something, but yeah. Because we do have separate notations, right? And capital F of x does not mean the same as small f of x.
Okay.
Yeah. Vaibhav, how far are you?
Ma'am, I'm solving. I'll send you what I've done in just a couple of minutes.
Yeah. Vanshita, how far are you? Are you solving the second sum?
Yeah, I'm sorry.
Okay, good. So for Savri and Mihir, let us put the third question on hold for now. I'll get back to it. And again, I would say that, the answers that you both have seem correct to me. I mean, there is no doubt that it is wrong, but I think it is just a matter of the way the question is worded. And I'll have to check with the original reference if this question is exactly the way it was given in the original question. So, or have I interchanged any words? So I'll get back with that.
Okay, ma'am.
Yeah. So Isha, if you have anything which is infinity, so let us say infinity power 1. What is its value?
Infinity itself.
Infinity power 2
Same.
and 1 upon infinity?
0, right?
Yeah. So you got your answer?
Okay, so because it's a negative part.
Yeah, so the best thing to do here right now is to substitute in the values of alpha and lambda so that you know what the actual power is. So minus alpha plus 1 would be a negative number here, right?
Yeah, right.
Exactly.
Okay, okay.
So Vaibhav, the very first page that you have sent to me is correct. There's really no doubt about it. And then I think the only thing that you should be doing now is to try and so what X did you consider when you were figuring out the PDF of Pareto on the next page? Did you just guess a particular value of X?
So, ma'am, I put the
Because,
value of x as 129.61, the one we derived on the previous part.
but is that really the value of X? Or what was it that we derived in the first part? So I'm actually talking about the very first line of your next page, wherein you have written the PDF, right? Alpha times lambda raised to alpha upon lambda plus X raised to alpha plus 1.
Yes, ma'am.
So you have written 503 in the denominator. So lambda is 500, but who said to you that our X is 3?
Yes, ma'am, I made an error.
Yeah, so that is not how you can solve it, right? So you have to figure out something else for that. And I think the rest part of it is correct. Yeah. So the second part, the probability of X being greater than 129 is correct. And again, you can actually see that, the way we figured out our M was that 50% of the stuff lies above it and 50% of the claims lie below it. So you anyways didn't have to, solve for f of x. You could have just written 0.5. But again, it's worthy to check it again. No worries about that. And just get back to your PDF of x. And again, if you look at the formula, it gives you the particular value of x that you have to look at, or else maybe go to a step prior to that and try to substitute in the capital F values and see what you get. So that could be another thing that you can do. Okay, so yeah, so Vanshita, what you have done is again, the same kind of a mistake that Isha did. So let me just write this on the board once and for all. So if we try to figure out, so Vanshita, do you understand your mistake?
Yes.
Yeah. Isha. So Prajakta, have you understood everything from all the lectures that you have watched as yet?
Yeah, like from the earlier lectures, yes, but like for this question particularly, like it's kind of going over my head. So like I'll like look the lectures again, and like the 2 or 3 lectures I have to watch, I'll have to like watch it, and then I'll completely understand like what is going on in this question.
Okay, yeah, because I would say, the earlier you catch up, the good it is for you. And you can
Yeah.
actually ask me all your doubts. But again, don't worry that you are not in the live lecture, so you cannot ask me doubts. Do message
Yeah.
me anytime on the WhatsApp. I will be available. So as and when, let's say you're watching lecture at 2 in the night, feel free to message me. I won't judge anyone. I will reply as and when I get time. So yeah, but just do message me if you really don't get anything. And again, so the way I like to teach is to take your input first, right? And then talk on about what should actually be done and how you can improve your thinking so that you can actually think about the right answer in the first place the next time. So I think I would really encourage for anyone who is watching the video lecture anytime, and if you miss any live lectures, that please do pause the video when I tell you to think in the actual video, and do think about it, and feel free to send me. I mean, I have my WhatsApp notifications on, and if I am free, I will check it right then and there, and I will reply to you. And if I'm busy, I will check later on, but at least you will get to know the way you were thinking, or was it like on the right track or not? Or maybe you can be the good judge of that itself, because you have the next of the recording part as well. But again, I would really encourage for you to just write in your notebooks, at least. I mean, not just sit and watch it like a movie. Okay, and I hope you guys are doing that.
Ma'am, I'm not able to figure out what the value of x is. Shouldn't it be 129.61 only?
Why do you think it should be 129.61?
So, ma'am, in the previous part where 0.5 was the value given, in that we substituted, we found the value of x and then we wrote that as m. So, I think that's why.
So, okay, the thing that you have to figure out is what?
What is
Is
x?
the distribution, right? You have to figure out the distribution because you are solving for G, right? So do you necessarily need a value, or do you need something which is in itself a function of X or W? So think of it as f of x. The way they have given you the formula for f of x is what? It's alpha times lambda raised to alpha upon lambda plus x raised to alpha plus 1, right? Wherein lambda and alpha are the known values or the parameters, and x is the variable into consideration, f of x, right? So the random variable is x. So if you are trying to figure out g of w, then you should have w, then you should have some function of w, right? Because this is not a mass function wherein we have all the chance of something happening at one particular point. I mean, there's nothing else value that your g of w can take except the one that you have just derived, right? Does this make some sense?
No, ma'am, I don't follow.
You don't follow. Okay, so can you check the second page that you have sent me, where you have the final answer for g of w? So tell me, what do you understand? I mean, what is g of w?
It's basically PDF of x upon the probability x is greater than m, right?
Yeah, it is a PDF, right?
Yes.
And what do you have?
Um, I have alpha, I have lambda. I do not know the value of x over here, right?
Yeah, so do you need to know the value of x? So, okay, if you open your formula booklet, let's say, and check out the PDF of Pareto, how is it given? It has the parameters and it has the random variable, right? X as the small x. I mean, it is the value that your capital X takes, but is it a particular value? Like, is it a particular number, 0, 1, or something else? No, right? It is a variable which can take any value.
Yes, ma'am. In the formula, it's not mentioned. It's a variable only, right?
It's a variable only, right? So again, just if you have a look at what you have calculated is, so you have figured out the G of W. You have figured out a value for G of W, right? So what does it say? That the PDF, so the way we plot any PDF, let me just draw on the board. Okay. So the way I plot any particular PDF is something like this. Okay, if it's normal. So the way you have done is you are saying that this is the PDF of the reinsurance company because it takes only one particular value, right? With the probability of 1. So again, so again, okay, also considering the fact that if you take X, I mean, you said that you were considering X value as the M, right, which is 129. So if you add 500 and 129, you don't get 503, right?
Yes, ma'am. Ma'am, that error I noticed, but apart from 129, I cannot figure any other value of x. So that's what I'm asking if I should substitute
Okay,
the value of x as
yeah.
129.1.
So the thing is that you don't have to necessarily solve for the PDF of X. What you will be doing is, if you figure out f of m, if you substitute instead of x, m. So let's say if you try to do this, so we have f of x, right? And what you are saying is you want to do this. What do you think this implies in words? The chance that you will observe this one particular value m, right?
Yes, ma'am.
Yeah. So I think what you should instead do is, so let me maybe just, okay, no, so we are here itself, right? So maybe what you can do is, so you did get up until here, right? So you wrote that your G of W is f of W plus M minus f of M upon 1 minus f of M, right? So what I want you to do now is substitute for these capital F's and to not substitute in for the other variables. So let's say if I write, and again, just to make it clear for us and leave no confusion, let us write the x here because uh, it's for us to remember that we are looking at the cumulative function of x. This is the value that x takes, right? W plus m. So if I were to write f of x w plus m, I'll have to first figure out what is my f of x, right? So my f of x is just 1 minus 500 upon 500 plus x raised to 3, right? So now I know something about f of x. Are you there?
Yes, ma'am.
Yeah. So again, so this is the general notation. So sorry, the general notation would be lambda upon lambda plus x raised to alpha. So what we will do is instead of substituting the values of lambda and alpha, let's just leave it at that and try to figure out the distribution for the conditional claims of the reinsurance company. So what we will do is we will substitute in for this f of x and this f of x. So for f of w plus m, what should I write here above?
Ma'am, your voice cracked. Can you repeat?
So I'm saying that for this particular value, what should I write here?
You could substitute w is equal to x minus m, right?
No. So again, remember the fact that we only know the distribution of x, right? We do not know the distribution of w as yet. So what I will do is I will substitute instead of small x, which is here, I will substitute w plus m. Because what I have to figure out is capital F of W plus M, right? So, and I know F of X, but I don't know anything about F of W. Do I? No, right? So what I will do is, I will just rewrite this. So I'll have 1 minus lambda upon lambda plus, instead of x, I'm going to write w plus m. So I'll have w plus m raised to alpha minus f of x m. So it will be again 1 minus lambda upon lambda plus m raised to alpha.
Yes, ma'am.
It is just the probability, 1 minus all of this. So it would just be lambda upon lambda plus m raised to alpha, right? Do you agree with this?
Yes, ma'am, I do.
Right? So now if I were to solve for this, in the numerator, I will have lambda upon lambda plus m raised to alpha minus lambda upon lambda plus w plus m again raised to alpha divided by lambda upon lambda plus m raised to alpha, right? So if I divide this with this, I get a 1 minus, I'll have lambda raised to alpha upon lambda plus w plus m raised to alpha again upon lambda raised to alpha upon lambda plus m raised to alpha. So this and this will get cancelled and you will be left with 1 minus lambda plus m raised to alpha upon lambda plus m plus w raised to alpha. So what is this? Oh, and again, when you wrote that, your small g of w equals this, so that is not exactly correct, I would say, because this, okay, let me just do this and not this, because this is what? This is capital G of w, right? So if you have a look at your previous notes from our previous lectures, you will realize that this is the CDF of W, not the PDF of W, right? So again, when you write small g of W being equal to this, that is faulty. You have to write capital G of W. So now this is the capital G of W and this is how it kind of looks like. So if you compare this, you can see that this in a way follows Pareto with lambda, comma, and instead of W, you have lambda plus M, right? Because, so sorry, instead of lambda, you have lambda plus M, and W is just the random variable which is into consideration. So if you substitute W instead of X, and if you take lambda plus M instead of lambda, and you figure out this G of W, you will get the same answer if you use this distribution, right? So now you can say that your W follows Pareto alpha comma lambda plus M. And then when you figure out its expectation, I think it's only easier that you just have to take lambda plus M upon alpha minus 1, right? And you know the values of lambda, M, and alpha. But again, this is just one method to do it. You also have another method that you can do. So let me just write that. So in that method, what you will be doing is you will be using this formula. So this is, I would say, method 1. You can also use another method. So you use the formula that your expectation of W is expectation of X minus M upon the probability that X takes a value greater than M. right? And we know already that this is just 0.5. So if we try to figure out our expectation of x minus m, what you can do is you can take the integration of x minus m f of x dx, and you again just
Excuse me, ma'am.
yeah,
So the mean of W is 314.81.
yeah.
All right.
Who was that?
Webhub.
Okay, yeah. Did you get the answer?
Yes, ma'am. Thank you.
Yeah. Vanshita?
Yes, ma'am, I'm doing the last part.
Okay, yeah, good.
Ma'am, can you check if what I've sent you is correct?
Yeah, just let me check. So first of all, do we have to add the 64 or subtract the 64? We'll have to subtract it, right?
Pardon, ma'am?
So the 64 that you have added for expectation of Z, you should
Right.
ideally subtract that 64,
Yeah.
right?
But the other part, like after that, it is right.
Yeah, so yeah, after that it's correct, but again the value that you have gotten is not quite correct for the first integral as well.
Why?
Yeah, let me just show it to you once. So let me just check for Vanshita's answer first. Yeah. So Vanshita, your expectation for Z value is indeed correct. Now figure out the other parts and show me the final answer.
Ma'am, I sent you the final. Oh, sorry. Yeah.
That is not the final answer. Okay.
Yeah.
Yeah. And please do not forget to write your DXs. So I'm saying this to Vanshita. You forgot to write a DX.
Oh, yeah. Thank you.
Yeah. Isha?
Yes, ma'am.
Yeah, you did change the limits as well, right? Okay, I'm trying to solve. So, yeah. I think you must have done some calculation error, Isha, because all the integration and stuff that you have done is indeed correct.
Uh,
Just
Let
check your
me recheck
calculation.
it. Yeah.
Just check your calculations once.
Ma'am, in the second last step, in the second part of this thing, have you put lambda t raised to minus alpha?
This? Oh, so I only took alpha, lambda raised to alpha as common. So I didn't really use this step. So what I did here was I took lambda outside and I didn't take this as common. But in the next step, I took them as common. So So just don't try to follow my steps. If you try to do it on your own, you would get either this or this. So yeah, and anything is fine. So I actually don't even have a calculator with me right now. And I think I'm gonna leave it at that, because then you just have to substitute in and then substitute in again and you'll get your answers.
Ma'am, can you tell me what the answer is?
It is 314.98. So, okay, let me just maybe go here and then write. Um, Maybe I will just write it here.
Ma'am, I got my mistake. So it was just a minus sign.
Okay, that's good. Yeah, I'm not solving this, I guess. So I guess okay, so Vaibhav, 2 to 2 is only your expectation for x minus m. Sorry.
All right,
So
ma'am. Got it.
2,
Got it. I got it.
so 2 to 2 is actually just this part. This is too bad. Okay, so has everyone understood up until this part?
Yes, ma'am.
Okay, so I think let us now all try to do the MLE part of it. So I'm going to skip a third part of the question and we'll directly move to the fourth part, which I'm putting in the group. Yeah, so I want you all to read the question and try to see what do you understand of it. Has everyone read the question?
Yes, ma'am.
So what do you think we are to do?
We don't have to use the Pareto distribution for the parameters. We have to estimate them through MLE.
Okay, when you said that we don't have to use Pareto distribution for that, I wouldn't say that, that's the correct way to put it. So
No, the given parameters of Pareto distribution. We don't have to use the given parameters.
Exactly right. So we do have to use the fact that our F is Pareto, but we cannot use the values which we already know of alpha and lambda. We expect to derive them by ourselves using the MLE, right? So, okay, again, whose MLE do we have to care for? Reinsurers, right? So, what distribution should we use? We'll have to use the conditional distribution of the reinsurer, right? We cannot go on using the normal f of x, which is our Pareto 3, 500, right? Because that is the distribution of all the claims, right? Not of the claims which are only pertaining to the reinsurance company. Oh, sorry, I was on mute, right? Okay, so what I was asking is, what do you remember from the likelihood that we discussed during the lectures? And what do you think I can do here? Anyone? Let us solve this together. So I want inputs from everyone. So how do you think I should write my likelihood function here? What should be my first step at least? Anyone?
We have to write product of the PDF.
Yeah, we have to take the product of the PDFs, right? So again, if you are looking at W's, then we will have to take the product of the PDF of W's. So it will be from 1 till n, let's say. And we have f of w x I. So this n is actually given to us in the question. Let me write it here. So consider till xn. Okay. So do we know the distribution of W? So again, I think for those who have solved the second part of this question using this method, wouldn't have done what I guess Weber did. So what Weber did was he tried to substitute in the values for capital F here. So as to figure out the capital G of W, which is the cumulative distribution function of W, right? And if you solve for it, so let me just walk you guys through this. So this is the formula that we derived in the lectures, right? And now I'm just substituting this f of x, small x. So instead of small x, I'm substituting w plus m here. And again, instead of x, I'm substituting m here. And I'm just solving for it, and I get something like this. So now what I do is, I compare this CDF with the Pareto CDF right here. And again, instead of x, I have a w here. So my x here is just replaced by w here, and my lambda everywhere is being replaced by lambda plus m. So I see that my w follows Pareto alpha comma lambda plus m. Does this make sense? Does this make sense to you guys? Take some time, a minute or two, to think this through. Did everyone understand what I tried to explain?
Yes.
Okay. If you do not, please let me know. So the formula that I have written up there, we did derive that in the lectures, right?
Yes, ma'am, got it.
So try to solve for the likelihood function now. Try to figure out the likelihood for the reinsurance, the expression itself. You don't have to solve, you just have to find out the expression. And what about others?
Understood, ma'am.
So for those who have understood, try to figure out the expression for the likelihood and send me your working. Actually, I don't think there's much to it. So once I get a yes from everyone, if they have understood this, if you haven't, please do ask me. Prajakta, are you understanding any of the things that we are doing right now?
Yes, no, ma'am. I was just asking you to just repeat once again what you just told.
What
Like,
I just told? This
yeah.
derivation, you mean?
No, the likelihood part.
The likelihood part. Okay. So let me just. Yeah, so this. So again, let us remind ourselves our W follows Pareto with parameters alpha and lambda plus m. Okay. So again, I think there's really nothing much that you can do here, right? So what you have to do is just substitute in for the F and you substitute in the Paretos. So you have alpha times lambda plus m
Yes,
raised to
ma'am. Got
alpha.
it.
Got it, right?
Yeah.
Perfect.
Ma'am, just a doubt. We can directly use, we can directly even use that formula, right? F of W xi is equals to f of x upon probability of x greater than m.
Yeah, yes.
Okay.
But then again, you won't, you have to get the answers in terms of alpha and lambda. You just need to know that.
Yes, ma'am.
Yeah. Does this make sense to everyone?
Yes.
Yes, ma'am.
Yes, ma'am.
Okay. So now if we were to do the same thing for the direct insurer, which is the seeding company, try to figure out the likelihood function for the insurance company. Does anyone have any ideas on how should we go about solving that?
So, ma'am, instead of W following Pareto with alpha and lambda plus m, we'll just do X follows Pareto, right? The original equation, and then find out.
Yeah. But again, you do so. First of all, instead of just seeing to it that it will only take one value x, do we remember the distribution of y? It does not only take the value x, right? It has distribution. So try to remind yourselves of what are the values that y take.
So for x less than m, we'll have x,
Yeah.
and for x, yeah, greater than equal to
Yes.
m, we'll have m.
Right. Okay. Good. So you have to use those two likelihood functions, right? Two separate likelihood functions.
Yes.
Yeah. So do that.
Ma'am, in that the first part would be again a conditional expression because we have to consider x less than m.
So again, so do we have to really do that? So what we are now looking at is we don't want to derive the function, right? We just want to figure out its likelihood of happening. So the chance that we observe a x which is less than m.
Sorry, I didn't follow.
Okay,
I
so
mean, I
maybe,
didn't get it. Yeah.
yeah. So maybe let me write it on the board. So what we have is, we have y taking the value x and taking the value m. So this happens in the cases of x being less than m, and this happens in the cases of x being greater than m, right? So now if I were to see my f of y, what I can have is, for all the times I have observed my claim amount less than or equal to m, my f of y will be equal to what? What should I write here?
X.
So I'm writing f of y here. This is not the value.
F of
So
x.
it will be f of x.
Sorry.
Exactly. Yeah. And if I have x greater than m, what should I be writing here? Just the probability that my x will be greater than m, right? Because that is, okay, so let me just maybe describe this. Because this is all the times seeding company is m amount. Okay, does this make sense?
Yes, so it by default gets considered when we take the multiplication, I mean the product of f of
Yeah,
x.
yeah. So now if I were to write its likelihood function, oops. Yeah, so now if I were to write its likelihood function, how will I write it? Anyone? So the very first thing that I should be doing is pi I going from 1 to, what should I write here? Anyone?
And
Pi goes to
M,
m.
right? It goes to M. But then again, I know that my out of those M claims, N claims involve reinsurer. Okay, so we have to be mindful of that as well. And the rest of the cases are the cases where we do know, the actual claim amount. So, okay, and what should I do next? Anyone?
Pi from I is equal to 1 to m minus n f, f of x
Yes.
uh, into pi of j equal to 1 to n
Okay, yeah,
probability of x greater than n.
right.
Yes.
Does this make sense to everyone? So, okay, again, maybe I can write that this part corresponds to this part here, and this part corresponds to this part here. Does this make sense? So again, just to remind ourselves, This is our f of x, okay, not y. So we started with y, but we have x here everywhere. So now what should I be doing next? Nothing much, right? I can just substitute in this f of values and just figure out the rest of the stuff. So maybe what I'll have here for f of x will be something like alpha lambda raised to alpha upon lambda plus. Okay, so again, okay, so let me ask you guys one more thing. Should we have written xi here?
No, ma'am. Here the number of claims is y, right? So it will only be x.
What did you say? Can you say that again?
Won't it be only x, not xi? Because here the number of claims y go to m. Like it's not xi, x1, x2, x3 going till xn.
Yeah, right. So we have observed values in terms of small y's. So again, I mean, writing xi here, this is just a notation matter, I would say, but again, it's just better to write yi here. Okay, because that is what takes the value from 1 till n, and basically all the stuff that we are trying to figure out. So this m is just another value taken by this y. So again, I do write x here, and here I can change a bit. So I can maybe write my f of y, but I have to be mindful that I'm taking this with respect to x. Okay? Does this make sense?
Ma'am, over here, M is like all the number of claims observed, including both.
Yeah, so small m. So if you see here y1, y2, yn, so till small m, these are the observed values. And n claims involve reinsurer.
Okay, sir.
So, yeah. So m minus n claims, we know the actual value.
Ma'am, and I didn't understand the fx y, I think.
Okay, so what I did was, I mean, it is just a matter of notation, I would say. So if I would have denoted my claim amounts as X, I would have written X here. But what I'm saying in the question is that I have denoted my observed values as Y. So whatever it is, the value that I'm observing for any random variable is denoted by small y here. So again, even though I'm taking my f of x here, my small x, which is the observed value of capital X, is just y, because we have y here instead of x.
Okay, understood.
Does that make sense? What about others? So, okay, so now if you will write lambda plus y high here, that's fine. And then what you can do is just alpha plus 1 here, and you have this from 1 till m minus n. So you just write this as it is. And for this thing, you can actually figure out, right, what's the value, or can you figure out what is the value for this? Anyone? You cannot, right? Because you shouldn't be substituting the values of lambda and alpha here, neither m. So you will have lambda upon lambda plus m raised to alpha, which is the 1 minus f of xm, and you will raise this to n, right? Does this make sense to everyone?
Yes.
What about the rest of you guys?
Yes, ma'am.
Yes, ma'am.
So yeah, that's about it, I would say, for today. If anyone has any doubts, please ask me in the WhatsApp group. And yeah, I guess that's all for today, I would say. Oh yeah, and again, is it fine if we take a lecture on Sunday later in the evening, or maybe we can take it in the afternoon?
Afternoon would be better.
Okay, and what about others?
What about morning?
I'm fine with morning.